Welcome back, welcome back, welcome back. I'm Miss Lisa Blackburn, and I teach science and math. And this is my YouTube channel where we talk about everything I want to, science and math. And today we are doing atoms in the periodic table in chemistry class. Get my pens right on the board. All right, so if you're in my class, watch the video, and the notes are on Canvas, but I have a copy of the notes for you in the inbox over there and the makeup box over there, so you can pick it up if you just write down the blanks for now. All right, so the story of the atom. I like this part of science. Another teacher was saying they did not like this at all, and I think it's so interesting. It's like, where did chemistry come from? And what's the history? Well, it goes all the way back a long time. See our little guy? What does he look? Where does he look like he's from? Rome. He is actually from Greece. You were close. His name is Democritus, and he gave us the term atoms. Let me get my pen going here. Guess we'll do that one. Let's see if it'll let me write. Oh, look at that. It's right where it's supposed to write and everything. And atoms is a Greek word for indivisible. And he was an ancient Greek. So you can say the Pledge of Allegiance, one nation, atoms for liberty and justice for all. It means indivisible, okay? And this is what he did. He was a philosopher, not a scientist. And he was out on a beach. And he said, this beach is one thing. It's a beach. But it's made out of many things, grains of sand. I'm one thing. I wonder if I'm made out of many little things. I'll call them atoms. He was exactly right. And he just thought of it. I'm very impressed with Democritus. So everything is made of atoms, was his idea. Now, at the same time, there was another ancient dude, Aristotle, who said matter is uniform. He started also thinking like philosophy and started thinking that there was a sameness to matter and that maybe that there was some sort of patterns that could be discovered, okay? So then for a long time, there wasn't really chemistry. We had ancient Greeks and then a long, long time. Okay, what was going on in the long, long time? This is the dark part of chemistry. It's the part that's witchcraft. So then came the Alchemist, and these were pretty much people who would practicing the dark arts. And their idea was to get rich quick. And they wanted to use magic to turn lead into gold. Both lead and gold are both very heavy. Lead is not very expensive. If you remember our reports, gold is very expensive. So they were doing other things besides that, but they were using potions, incantations, things like that. So this is sort of a dark past to chemistry. But we owe a lot to the alchemists. The alchemists are the ones who actually came up with a lot of the lab techniques and equipment that we still use today. And they did discover a lot of properties of elements, but they didn't know what they were. But they did the groundwork. They got it going. Okay, but we don't talk about them at all, other than we'll mention when we talk about the periodic table, they had symbols for some of the elements. We'll look at that. But other than that, that's all we talk about with them. So then the next guy who came along, who's sort of the father of chemistry, there's a lot of people who are called the father of chemistry, but he's one of them. His name is John Dalton. And he came up with this idea that is called the atomic theory of matter. The atomic theory of matter, okay? So he was a religious person. He was more a modern person. And he came up with the idea that everything is made out of atoms. Now remember, theory in science is different than theory in common speech. In common speech, I can have a theory. Like I used to have a fruitcake theory that nobody really likes fruitcake. It's full of alcohol, so it's preserved forever, and people would just re-gift it over and over again. But that nobody really liked it. Riley, put your phone away unless you're taking my picture. If you want to take my picture and show your mom how crazy your chemistry teacher is, feel free. Otherwise, listen. Okay, so my fruitcake theory is nobody really likes it. But then I met a girl who really likes fruitcake, and she said I would too if I had her grandmother's fruitcake. Well, she never gave it to me, so I still don't like fruitcake. But if you, in science, that's common language. I have a theory. You can have a theory about anything. Why people like a certain artist. Why, whatever in politics. You can have a theory, and that's common language. But in science, a theory is true. It's not like my fruitcake theory. And it is testable and observable, and it's gone through many, many experiments to prove that it's true. But if you do come across one that disproves it, then you toss it out. So I had to toss out my fruitcake theory when the girl said she liked fruitcake. Okay, so this is what he came up with. It's called the atomic theory of matter, and it's really important. He said that atoms are like billiard balls. Billiards is like pool. Anybody like playing pool? I do, but I'm bad at it. I had a cousin who had a pool table. He could wipe you out. He was so good. Okay, it was because he had the pool table. Okay, so he said it was like billiard balls. He said all matter is made of indivisible and indestructible atoms. Now, turns out that's not true, is it? But this is his theory that he came up with in the 1700s. Since then, it's changed a little bit, but we still agree with it. Okay, his second point was all atoms of a given element are identical in their physical and chemical properties. And atoms of different elements have different physical and chemical properties. That's kind of hard to read. It says different. Atoms of different elements combine in simple whole number ratios to form chemical compounds. Atoms cannot be subdivided, created, or destroyed when they are combined or separated in chemical reactions. And it's called the billiard ball model, because he said it was like a billiard ball. And that is this model right there. Draw a little thing to it. So what he's saying is that there's a small Lego that everything's made out of called atoms. You can't break down the Legos anymore. All of a certain element is the same, so all gold atoms are the same. And all gold atoms are different than other atoms. That they combine in whole number ratios. Water is H2O, not H3.5. Oh, it's going to be small number ratios. And you can't subdivide, create, or destroy an atom in chemical reactions. And it's called the billiard ball model. The thing that is different that we know about is we know that the atoms can be divided. It's all true, except we know that the atom can be split in nuclear bombs, right? But this was a pretty good thing. He had it pretty well figured out. The next guy coming along was J Thompson. By this time, they had figured out that about charges. They had a cathode ray gun where they could shoot a stream of charge at something. Didn't really understand it, had made the gun, was having a great time with it. And they decided, well, the atom must have some positive and negative in it. And it was called the plum pudding model. Now, we don't eat plum pudding, but it was a popular dessert. You can kind of imagine it as vanilla pudding with little negative raisins in it. Positive vanilla pudding with negative raisins. You could also think of it sort of like a round muffin with chocolate chips in it, because in England they call puddings desserts, and it could be a baked thing more like a muffin. All right, so I got enough time to tell you about JJ before it's time to go. All right, so he had this cathode ray tube. How cool is that? And it would shoot positive particles that could be attracted or repelled by a magnet. How cool is that? The plums were negative charged electrons, and the pudding was positive charged goo. So he did experiment. So that was his model, and it is this right here. Now, he had a friend, Ernest Rutherford, who decided, and there's our Jell-O plum pudding. He had a friend, Ernest Rutherford, who was going to prove his model was correct. And we will stop there and pick up maybe further on with fourth period. But you'll get to hear more about the next guy in the story of the atom. Science and math is great. See you later.